Hello dear student, welcome in KRT Arts, BH Commerce and AM Science College, Nasik. Myself, Dr. V.S. Shinde, Assistant Professor, Department of Chemistry. Student, in previous lecture, we have seen introductory part of photochemistry, some reactions of photochemistry, and also two laws of photochemistry, Grotthus-Rapes law and Stark-Einstein law. In today's lecture, we will discuss recapitulation of fluorescence and phosphorescence. Okay, so let's see. Learning objectives. At the end of this lecture, you will able to understand what is exactly fluorescence and phosphorescence and also prompt and delayed reactions. Okay, at the end of this lecture, you will able to understand exactly what is fluorescence, phosphorescence, prompt and delayed reactions. So let's start with this diagram. What is fluorescence and phosphorescence? What is the ISC, that is intersystem crossing? Many concepts are there: ground state, excited state, fluorescence, phosphorescence, internal conversion. All these concepts I will explain in next lecture, that is in Jablonski diagram. But this lecture is only for fluorescence and phosphorescence, so I explain here only fluorescence and phosphorescence. So what is fluorescence? As we see that this is the excited state and this is ground state. This is singlet excited state, when this is ground state. This is triplet excited state and this is ground state. Okay, so fluorescence, the molecule in the excited singlet state S1, the molecule in the excited singlet state S1 return to the ground state S0 with emission of radiation. Okay, this process takes place within 10⁸ seconds, -8 seconds. This is spectroscopically allowed transition. Okay, I again repeat, the molecule in the excited singlet state S1 return to the ground state S0 by emission of radiation. This process takes place within 10⁻⁸ seconds only, and this is a spectroscopically allowed transition. The emission of radiation by this mechanism is called as fluorescence. The emission of radiation by this process is nothing but fluorescence. While in case of phosphorescence, we can simply say that the molecule in the excited triplet state T1 returns to the ground state S0 by emission of radiation, but this process is spectroscopically forbidden process and it takes place in about 10⁻³ seconds. The fluorescence process is much faster than phosphorescence process. You have to only remember here, in case of fluorescence, the transition from the molecule in the excited singlet state return to the ground state, while in case of phosphorescence, the molecule in the excited triplet state return to the ground state. Okay, it occurs much faster as compared to phosphorescence. So let's see the points one by one. What is fluorescence? The process in which its absorption of energy by immediate emission of light. What is fluorescence? The process in which its absorption of energy by immediate emission of light. Also, the emission of radiation suddenly stops after removal of source of excitation. The emission of radiation suddenly stops after a removal of source of excitation. The absorption occurs in short time interval. The fluorescence process in which the absorption occurs in short time interval and it involves transition from ground state to singlet excited state and do not change the direction of the spin. The absorption occurs in short time interval and it involves the transition from ground state to singlet excited state and it do not change the direction of the spin. In fluorescence, the absorption and emission is very fast. In fluorescence, the absorption and emission is very fast as compared to phosphorescence. while the emitted photon has lower energy than the absorbed photon. Those photon is emitted one, it has lower energy than the absorbed photon and the emission occurs to longer wavelength than incident light, and the emission occurs to longer wavelength than the incident light. Okay, I again repeat, the process in which it's absorption of energy by immediate emission of light. This is nothing but the fluorescence. The emission of radiation suddenly stops after removal of source of excitation. Third one, the absorption occurs in short time interval and it involves the transition from ground state to singlet excited state, and it do not change the direction of the speed. While the in fluorescence, the absorption and emission is very fast as compared to phosphorescence. Also, the emitted photon has lower energy than the absorbed one. I again repeat, the emitted photon has the lower energy than the absorbed one and occurs to longer wavelength than the incident light. In fluorescence, such as those seen in common fluorescent tube, as we know that the fluorescent which are seen in common fluorescent tube, phosphorescent material, store absorb energy for longer time as process required to re-emit energy occurs less often. Okay, this is about the fluorescence. Okay, so let's see phosphorescence. See, if we are comparing fluorescence and phosphorescence, the phosphorescence process is slower as compared to fluorescence. Okay, and it occurs from triplet excited state to ground state. So the process in which energy absorbed by substance is released relatively slowly in the form of light called as phosphorescence. What is phosphorescence? The process in which energy absorbed by substance is released relatively slowly in the form of light called as phosphorescence. The emission of radiation remains sometime even after the removal of source of excitation. Here, the emission of radiation remains sometime even after there is removal of source of excitation. Also, here we observe the inter-system crossing, means from singlet state to triplet state. In case of phosphorescence, the electron which absorb the energy undergo usual inter-system crossing into a energy state of higher spin multiplicity, means from a singlet state to triplet one, usually a triplet state. As a result, the excited electron can become trapped. As a result, what result from this? The excited electron can become trapped in triplet state, which only forbidden transition available to return to the lower energy state, which is only the transition available to return to the lower energy state. This transition is almost forbidden transition, spectroscopically forbidden transition. I again repeat, phosphorescence involve intersystem crossing, means in phosphorescence, electron which absorb the energy undergo usual intersystem crossing. This electron undergoes usual intersystem crossing into a energy state of higher spin multiplicity, means from singlet to triplet one. As a result, the excited electron can become trapped in the triplet state. This excited electron then trapped in the triplet state with only forbidden transition. So this is only the forbidden transition which is available to return to the lower energy state. So this transition is spectroscopically forbidden one. Also, phosphorescence material does not immediately re-emit the radiation absorbed. Phosphorescence material does not immediately re-emit radiation absorbed. Whatever they absorb the radiation, they does not immediately re-emit that radiation. And also in phosphorescence, the transition observed from singlet ground energy state to excited state and involving change of spin state. Here we observe the transition from singlet ground state to excited state, but here we observe the change in spin state. Okay. Also, the emitted photon has lower energy than absorbed photon. This is the important one. Whatever the emitted photon is there, it has lower energy than absorbed photon, and emission occurs at lower wavelength than fluorescence. And here, emission occurs at lower wavelength than the fluorescence one. Okay, so this is the phosphorescence material. Student, if we are comparing the fluorescence and phosphorescence, simply I explained here 3 to 4 points. If in case of fluorescence, it's absorption of energy by atom followed by immediate emission of light. In phosphorescence, we say that there is immediate emission of light, while in case of phosphorescence, there is a delayed emission of light. Immediate emission of light in case of fluorescence, while uh, in phosphorescence, delayed emission of light. While in fluorescence, the emission of radiation suddenly stops on removal of source of excitation, while in case of phosphorescence, the emission of radiation remains some time even after removal of source of excitation. Okay, so in case of fluorescence, the excited atom has comparatively short lifetime before it transitions to lower energy state. I again repeat, in fluorescence, the excited atom has comparatively short lifetime, while in case of phosphorescence, the excited atom has comparatively long lifetime before it transitions to low energy state. In case of phosphorescence, the time period of the absorption and emission of energy is very short. The time period of absorption, it requires the absorption period and emission of energy is very short, while for phosphorescence, the time period of absorption and emission of energy is comparatively large. Okay, if in case of fluorescence, the absorption occurs over a short time interval and it involves transition from ground state to singlet excited state and do not change the direction of the spin. While in case of phosphorescence, it involves a transition from singlet ground state to excited triplet state and involving change in spin state. Okay, and if we can want to give the example in case of fluorescence. For example, jellyfish, vitamins, these are the example of fluorescence, while phosphorescence, the glow remains for some minutes even after dark. Okay, so let's see prompt and delayed reaction. This was about the fluorescence and phosphorescence. Also, we can differentiate that fluorescence and phosphorescence. Now see prompt and delayed reaction. See, excited state dissociate promptly, lifetime is short. In case of prompt reactions are those reactions which occurs less than 10 picoseconds, while delayed reactions having the reactions which having great occurs greater than 10 picoseconds. What is prompt reaction? That reaction occurs less than 10 picoseconds, while the delayed reaction, that reaction occurs greater than 10 picoseconds. This is the example having chromium complex. CrCO6 after HNu, it gives CrCO5 plus CO, while in case of CONH3 Cl 2 plus HNu, it gives CONH3 2 plus Cl. Both reactions are called as prompt photochemical reactions, means maybe this reactions occurs less than 10 picoseconds. In prompt photochemical reaction, there is involvement of rapid dissociation of ligand upon photoexcitation. After photoexcitation, it involved rapid dissociation of ligand. Is there is rapid dissociation of this carbonyl and rapid dissociation of this Cl upon photoexcitation. These reactions results from DD transition. Such kinds of reactions are result from DD transition. I again repeat, what is prompt reactions? Which occurs less than 10 picoseconds, while delayed reactions are those reactions which occurs greater than 10 picoseconds. These both reactions are nothing but the prompt photochemical reactions. It involves the rapid dissociation of ligands upon photoexcitation. These reactions result from DD transition. While delayed photochemical reactions involve ligand to metal electron transfer. In case of prompt reactions, there is DD transition is there, while in delayed photochemical reaction, it involves ligand to metal electron transfer. Ligand to metal, not metal to ligand, ligand to metal electron transfer. Some long-lived excited states associated with electronic transition in bonded compound may also lead to delayed photochemical reactions. Also, some long-lived excited states which associated with electronic transition in bonded compounds. There are some bonded compounds with electronic transition. They also comes under the delayed photochemical reactions category. For example, the reactions of ruthenium bipyridinium 2 plus created by photon absorption in Ml charge transfer. Here there is metal to ligand charge transfer. Okay, so the reaction of ruthenium bipyridinium 2 plus created by photon absorption in Ml charge transfer. Why here is Ml metal to ligand? Because here is bipyridine ligand which contains the conjugated cysteine. So obviously here is Ml charge transfer. So these are the reactions for delayed reactions and prompt reactions. Okay, student. So in this lecture, we have seen what is fluorescence, what is phosphorescence, and also prompt and delayed reaction.